Hi team, this is Dr. Crystal Nagallo, and welcome back to Doctor's Notes. It's been quite a while, it's been busy everywhere, including the clinic, which is wonderful. And so I regret that I do not have a lot of office hours time before your last exam. So in this video, I will discuss key concepts of the digestive system, and I'll make sure to cover a lot of the questions that were missed on quiz number 3 in the event that these questions or the concepts may show up again on the exam this week. So I'll go ahead and share my screen. All right, so the digestive tract, GI tract, gastrointestinal tract, also known as the alimentary canal, is a long tube that is open on both ends of the body, if you catch my drift. So it's one opening is found at the oral cavity where you find the mouth, and then the other end at the anus where stool exits. There are key organs of the digestive system, including the oral cavity, best found by locating the tongue. It's then connected to the abdominal pelvic cavity by way of this long tube known as the esophagus. Now, after the esophagus is a stomach. The stomach has several regions, including the cardia, which is hidden by this left lobe of the liver here. The cardia is going to be the first part of the stomach through which bolus, which is food matter that's entered in the GI tract, exits the esophagus. And then this top part here is going to be the fundus. And then this last part is going to be the pyloric region, which is aptly named because just after it is the pyloric sphincter, which is where smooth muscles will contract to help prevent the backflow of bolus from the duodenum, which is the first part of the small intestine, back into the stomach. There's also two curvatures named appropriately by size. Here's the greater curvature right here, and here's the lesser curvature. So that brings us to the duodenum. The duodenum has 3 sections. You're going to want to know that really well: duodenum, jejunum, and ileum. If it helps at all, I've remembered them in the following order based on the acronym DJI, kind of like the Dow Jones Index, like the stock market entity. We'll talk about histologically why there are 3 regions of the small intestine, and you'll see it's because there are specific features that you find in one that you don't find in the other. After the small intestine, there's going to be a sphincter, valve specifically is what it's called. It's called the ileocecal valve. It is located in between the ileum, which is the last part of the small intestine, and then the first part of the large intestine, which is known as the cecum, which is going to be this big bulge part over here. And then if you follow how stool travels throughout the abdominal pelvic cavity, you'll see how the different parts of the colon are named. This is the direction in which stool travels. Here's the ascending colon, transverse colon, because it's in the transverse plane, and then here's the descending colon, and then it's going to curve over to become this short section here called the sigmoid colon, and then you've got the rectum followed by the anus. Every time there's a curve in the colon, that's known as a flexure. So here's the right flexure, left flexure, and the sigmoid flexure, where the descending colon becomes the sigmoid colon. Now, the right colonic flexure is also known as the hepatic flexure, and in tribute to the right upper quadrant where you find the liver, and then the left colonic flexure is also known as the splenic flexure, where you'd also find the spleen, not pictured on this image. With that being said, there are several other organs that we consider a part of the digestive tract. They're specifically known as accessory organs, mainly because they're not actually a part of this long tube we just talked about, but they're located somewhere around the tube, and they contribute some sort of fluid or have some sort of role to play in digestion. So starting with the 3 salivary glands, you've got the parotid, submandibular, and sublingual. Of the 3, the parotid is the largest. The parotid salivary glands are located anterior to the ear. And then the sublingual and submandibular, aptly named. The submandibular will be found below the mandible, so below the jaw, and the sublingual, lingual in reference to the tongue, will be found below the tongue. There's also the liver, and the pancreas. We'll start with the pancreas first. So 3 main sections you want to know about the pancreas: the head, body, and tail. The head is going to be the roundest part, which will always make contact with the duodenum, which again is the first part of the small intestine. Now the body is going to be the middle section, and the tail is going to be the pointy end, which always is on the leftmost side of the pancreas. So you want to locate the duodenum first and then allocate where the head and the tail of the pancreas would approximately be found. The pancreas has certain histology, which is a review from the endocrine system we talked about earlier this semester. If you recall, the pancreas has both exocrine and endocrine function, and the reason why we're talking about the pancreas again is because this pancreatic acini, so all the cells that are outside this islet of Langerhans, the islet of Langerhans are again a part of the endocrine system because they have alpha, beta, and delta cells, which make glucagon, insulin, and somatostatin respectively. Insulin and glucagon are so important for regulating blood sugar levels in the blood, and they require access to the capillaries or blood vessels to get to different parts of the body, and that's why they're part of the endocrine system. However, if we talk about the pancreas now, because the surrounding cells, the pancreatic acini, produce pancreatic juices, specifically known as enzymatic and digestive enzymes, which will be put into the duodenum by way of a duct. So exocrine systems don't need access to blood vessels because they don't have to go to a place very far away. In this scenario, digestive enzymes need to get to the nearby duodenum, and they do so by accessing the pancreatic duct, and the pancreatic duct will enter the duodenum at a section known as the ampulla, where you'll specifically find tissue that is referred to as the duodenal papilla. That brings us to the liver. The liver is found in the right upper quadrant. It's a huge organ, so important for detoxification processes and activation of certain metabolites, but it's also responsible for producing bile. Now, bile is produced in the liver, but it's stored in the gallbladder, which sits underneath this right lobe. Generally, the right lobe is larger than the left lobe, and of course, in anatomy, the bigger something is, we find different things to name subparts of said big structure. So here is a posterior view of the liver. Here's the right lobe. What you want to look first for is the quadrate lobe, which is going to be more anterior. Here it is here, appropriately named the quadrate lobe. Quad for 4 sides, so here's 1, 2, 3, 4. Again, more anterior than the caudate lobe, so I always look for the quadrate lobe first, follow that same section towards the posterior, and that will lead you to the caudate lobe. There are certain structures in a histology slide that you might want to be aware of with respect to the liver, and that's, can you locate the portal triad, also known as the porta hepatis? In order for it to be the portal triad, try referring to 3 things. It's got to have 3 things, and the 3 things it's got to have is a bile duct, a branch of the hepatic artery, and a branch of the hepatic portal vein. Now, here's a really good portal triad. Okay, the hepatic artery is going to be round and lumen. Okay, so right here, vein more flat, that's right here, the hepatic portal vein, and the bile duct will be darker in staining, and it's going to have cells surrounding the lumen that you typically will not see in a blood vessel because it is not. That brings us to several slides pertaining to histology, and really the best way to differentiate these is to focus on structures you expect to see. So for the stomach, gastric pits, that's all these white dips over here, okay? Now, 3 sections of the small intestine. So first, the duodenum, you want to see villi, and then these Brunner's glands. For jejunum, more pronounced villi, see how they're more apparent than here and here. And then you've got the ileum, some villi, but they also have Peyer's patches here. Large intestine kind of looks like the stomach, but it is not, because here there are gastric pits. Here there are no gastric pits. Instead, there are many white cells known as goblet cells. That brings us to a summary on some of the digestive hormones that are important to know. So gastrin is one of the cells, released by one of the cells called G cells in the stomach. It is released in response to when food matter or food stuffs enters the stomach. It signals nearby parietal cells to secrete acid and basically gets the stomach churning as part of mechanical digestion. Once bolus moves into the duodenum, it's technically known as chyme as it mixes with all the digestive juices. Now, in the duodenum, several things are secreted, including GIP, which is gastrin-inhibiting peptide. It basically tells gastrin to stop because there's no need for it to be active anymore because there's no more food matter in the stomach. What chyme in the duodenum will also do is secrete secretin and cholecystokinin, abbreviated CCK. Secretin will encourage the release of bile, which is an emulsifier for fats from the gallbladder, and then CCK will help with the secretion of secretin from the gallbladder, but also help activate or make the digestive enzymes in the duodenum as active as possible, as it takes care of most of the chemical digestion that occurs in the duodenum. What's not listed here but is on your terms list is somatostatin. Somatostatin basically halts everything. It halts what's happening, what gastrin is doing in the stomach. It also halts what these enzymes, these hormones, secretin and CCK, are doing in the duodenum. And that concludes some of the things that I wanted to review in hopes to help you remember some key things as you walk or sign onto the exam in the next several days. As always, I want to pay tributes and give credit to GCU, from whom I have borrowed and adopted these slides. I hope you find this video very helpful, and I wish you all the best.